Away we go. So, today, our main focus, even though it's still going to be with equations, is going to be locked in more on the geometry part of this. So as I move this up, again, make sure we get dated with things for today. It's the 25th. Before you know it, it's going to be happy October, and then just kind of roll right from there. So we're going to do some equations today. We're going to solve for x, but then there's going to be one extra piece. We're going to be looking for missing angles, and we're going to have to be very careful to make sure that we're getting the angles that we're looking for, because I'm going to make a confession. I had to go change the answer key this morning because I hadn't read carefully enough. So it happens to me too. So first one we're going to be dealing with today is what's called an angle bisector. Okay? An angle bisector divides your angle into two equal pieces. So here's how we normally are going to mark that. So I'm going to take one of my colors, and I'm going to make kind of this curve in there with a line through it. And then I'm going to go to the other angle that gets created from this. And I'm going to do the same thing in a different color. Because since this is an angle bisector, angle STB, okay, the one that we've marked in blue, is equal to angle BTU. Thank you. So, whenever we see bisector mentioned, that's what's going to happen. So, AQ bisects angle RAD. Okay, so that means this is why it's important not to be having side conversations when the talking is going on. Those mean that those two angles are equal to each other. Okay? So we can call it equal. Another word we can use for that is congruent. So whenever we see bisect, it means those two angles are the same. So if they have to be the same, that means that 7x minus 60, this angle here, my blue angle, has to be equal to my red angle, which in this case is the 4x. That's why I wanted you to add the colors, so we can start seeing what goes with what. Once I get here, though, now it's a flashback to our last lesson. Because now the idea becomes, and I can go back and look if I need to, I need to get all my x's on the same side next. And we talked about how you can do that either way with these, but that it probably is going to be easier to get them all to the side where there's only x's. So we're going to move them over here to the 4x side. So how do I undo, or what's the opposite of a positive 7x? Subtract, or negative. Both of those are excellent. So we get that out of there. If I have $4 and I go spend $7 at the store, I'm 3 in the hole now. Now we got to be careful on this last step. Let's see. Oh. I'll let him answer. If I'm trying to get x alone, how am I going to undo this? Yes, sir. Okay. We've got to divide by negative 3. We're not adding and subtracting here, okay? It's not in between the number and the x. And then again, you can go to your calculator, or if you know it off the top of your head. One thing I can tell you for certain, you are not going to get negative x values for these, because then we'd have negative angles. That would be a problem. We don't want to have that problem. So x is 20, but I'm not done. Because I was asked to find angle RAQ. And so if I just start following RAQ, It's my blue angle right here where I had made my mark. So, RAQ is the 7x minus 60 angle, but I know what x is now. And I'm going to let you answer. So I'm going to substitute the 20 in that I just figured out, where the x goes, and when I plug that into my calculator to use my brain, I get, sir, 80. And I'm set. So again, the colors can come in handy on letting us label stuff as we go. Okay? So angle bisectors just always mean the two angles are going to be the same, and we solve it that way. My other one that we're going to run into is going to be what are called vertical angles, which means they're across from each other. So in this instance, for instance, ABC, so this angle, and angle DBE, this angle, would be vertical. They would be the same. Now, I know it doesn't say this here, but I'm going to tell you this as well. It's also true that angle ABD, so I'm just going to use two lines on this one, and angle CBE are also equal because they're across from each other and share the middle, our vertex, that one point. So, if you see two angles that are right across from each other, okay, and share that common point in the middle, like we do this time with C, that's going to tell me that this angle and this angle are the same, which means I can take their expressions and set them equal to each other. And now I'm back in a situation just like I was on the first example. So now I have this to actually help me on this one. So just like we had up here, this side has just x's, so I'm going to move everything this way. Here I had a positive 7x, I did minus. Here I got a positive 2x, I'm going to do minus. And then if I look up above, I'm like, hey, I divided both sides by -3, because that's what I was multiplying x by. Here I'm multiplying x by 3. I'm just going to divide. However, again, here, since we're dealing with angles, I can't just stop. I have to look now, and I'm like, okay, so BCD, this one, again, I can just follow with my color, is the 2x plus 39 angle, but I know what x is now. So again, I can plug that in my calculator if I'm not sure. I can try to see how much I can push my mind here as well. And I can find my angle. Those are the two types that we're going to be looking at today. Now, there are going to be a couple of twists and turns along the way, just like there always is with anything. So, keep this handy. We're going to be referring back to it here in a moment. We're going to head over to the practice on pages 7 and 8. We're going to be doing 7 and 8 today. And you're like, Hardy, we just got done talking about angle bisectors and vertical angles. What in the heck are you doing throwing this stuff back in. Because again, we've got to keep stuff in mind as we go. So, here's what this means. Midpoint is the middle, which means that DE and EF are the same. Okay, so here the DE equals EF. If that's the midpoint, it cuts it into two equal pieces. So if that's true, then 6n minus 3, this piece, should equal 2n plus 1, this other piece. You're like, okay. Now, here's where this is exactly the same as what we've been doing on the others. I still need to get all my n's on one side. You can move them either way you want. You just got to do the opposite. So if I want to get all my n's here, I want to do the opposite of positive 2n. You're like, Hardy, could I do minus 6n to both if I wanted to? You could. That would work just fine. But the goal is we want one of them to cancel out. So whichever one we choose is fine. Make sure we don't lose any of the pieces along the way, that we don't lose our equals. And now we're to a two-step equation that we're used to seeing. And again, if you show your steps in the color, hopefully that's going to make things stand out somewhat. Once all my n's are together, my goal becomes to get the n's alone. Undo the minus 3. That's why I keep kind of striving and saying we need to show our steps as we go. And I look and I go, okay, what am I doing to n? I'm timesing it by 4. My opposite of times is to divide. And we get to our n value. Okay, we figure out what the variable is. Here's the part where we have to be careful that Hardy wasn't this morning. I admit it, and I had to go back and fix things. So I look and I'm like, okay, so DE. DE is this piece right here. So that is the 6n minus 3 piece. But I know what n is. N is 1. So 6 times 1 is 6, minus 3 is 3. But here's where I got going too fast, and I'm hoping I can help some of you not do that. The last one, I assumed it was going to be EF. And I'm like, okay, it's going to be EF. It's not. It's DF. It's the whole thing. So, here's how you can figure out DF. You got two options. I could go in and say, well, DF is all of this stuff. So now I got to sit here and I got to do 6n minus 3 plus 2n plus 1. Now, do I really want to have to do all that? No. But let's just say I decided I would, because that's all I could think of at the time. So I'm going to stick in the 1 for n. I'm going to stick in the 1 for n. And then I would just type this in my calculator because it's like, dang, that's a lot of stuff to be keeping track of. I'd rather just... But here's what you could do. Here's the shortcut. I knew that DE was 3, right? I knew this part was 3. If I know that part's 3, and I know these two have to be equal because this is the midpoint, wouldn't that mean that that has to be 3 as well? And if that's true, df would just be 3 plus 3, which is 6. You're like, so wait a minute. So if I know this first answer, I just add that in again and I get the whole thing? It's true. So like if this would have been 5, this would have been 5 plus 5. If this was 10, this is 10 plus 10. So I can still just go back and substitute, but if I remember that one piece, and we've got it here now, you also could do it that way. Something to ponder. Let's play through a couple that we did like today, though, just to make sure. Again, we always want to make sure. So number 4. I see the little markings here. I didn't see the little dash I put in there with a 2, though, but I'm going to do that on these. So I look, and I'm like, okay, I don't remember. Let me get my example back. Okay, so here's my example. And so we just rode with 3x minus 6 equals 2x. Okay, we're just setting the blue and the red equal. And we're just going to exactly follow what we see here. Okay, I got all the x's to this side. Okay, so that'd be a minus. Because again, I got a positive, I do the opposite. And again, I just always got to remind myself on this. If the minus or plus isn't in between the number and the variable, this is multiplying. So I got to undo multiply. And I'm never going to get a negative answer for this. So little stuff like that can mean a lot. And then similar to what we dealt with up in number 1, be careful with what you're being asked for. HLJ. Okay, so HLJ. So I want this one. So I start writing. When I get to the x, we replace it with the x value that we found. 3 times 6 is 18, minus 6 is 12. And then I'm going to read the other angle because we never know. So we've got J, okay, J, L, K. So it's just this little one. It's not the whole thing. So it's just 2 times x. So it's 2 times 6. But Hardy, wouldn't I have known that one too, since they all have to be the same? You would. You would. If you did the math on the first one correctly, that absolutely would work. So you're like, okay. So all these things, we keep having stuff that's equal. And then I can kind of, I don't want to say cheat and get to the front, but you kind of cheat and get to the front. So the next 2 here, just like that one. Oh, we're still going. All right, Hardy, what do we got back here? Then can you stop harassing me? Maybe. Well, I'll consider it. Okay, let's see. So if we do 7. Angles are across from each other. So this one equals this one. So my equation, I'm just going to write it below here because that was getting a little tight up there. You're like, Hardy, you threw a curveball here. There's no other x's except the 5x. Okay. If there's no other x's, let's get to work. Let's just go and get that 5x by itself. By undoing each of the pieces as we go. And at this point, again, if we've been practicing any with our equations, we just are getting into the habit now of, oh, this is multiply, the opposite is divide. Find my answer. But then again, be cautious about what's being asked for. Let's see here, RQT. Okay, that says 5x plus 4, 1. So 5, there's my x. Pop that straight into my calculator. Get my answer, which I pretty much thought it would be because, again, I see this other one's 124, so that's good. But then the twist comes in that we might not have been prepared for, but we're going to be now. SQT. You're like, well, what am I supposed to do there? There's like nothing to plug in. How do you do something dumb? No. Here's where I've got to remember something. Okay? When you have angles that make a straight line, that equals 180 degrees. You're like, okay, so what does that mean? If I look at what I have up here, I'm just going to kind of re-sketch it here. I know this angle is 124. I just figured that out. I'm trying to figure out what this other angle is. So my job here is going to be to take 180, the straight line that these two angles make, and just subtract the angle that I already have. And that's going to get me my other angle. So even though there's not another variable there, we can still find that other number just by doing 180 minus that. And go about it that way. Okay? The rest of these are just problems like we've been doing. So again, give yourself a good opportunity. Give it a chance. Try some of these out. I do have the key up front, the corrected one. Okay? So if you are looking online, the first 3 questions, the second segment is going to be incorrect. So the one up front is correct, though. So give those a shot.